Hello everyone and welcome to the CyberWire's Research Saturday, presented by the Hewlett Foundation's Cyber Initiative. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down threats and vulnerabilities and solving some of the hard problems of protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us. And now a moment to tell you about our sponsor, the Hewlett Foundation's Cyber Initiative. While government and industry focus on the latest cyber threats, we still need more institutions and individuals who take a longer view. They're the people who are helping to create the norms and policies that will keep us all safe in cyberspace. The Cyber Initiative supports a cyber policy field that offers thoughtful solutions to complex challenges for the benefit of societies around the world. Learn more at hewlett.org/cyber.
Mid-November or so, we ended up coming across the malware.
That's Robert M. Lee. He's the CEO of Dragos Security, a company that specializes in the protection of industrial control systems. He's describing TRISIS, a bit of malware affecting safety instrumented systems, so far only in the Middle East.
Basically, there's not a lot of malware samples tailored towards safety equipment. There's not a lot of software that should be popping up on our radar related to safety equipment. So we were doing the normal sort of hunting thing, found the sample, took a look at it, pretty quickly realized it was weird, but we didn't immediately notify folks. I think this is also just an interesting aspect about intelligence for most folks. When you look at some of the ways people treat information sharing, it is a fast as I can get it, throw it out the door, let me see it kind of approach. And not to put anybody down, but that's typically the like DHS government kind of approach. They set up that standard with automatic indicator sharing program as well of as quickly as I get it, I'm going to throw it out the door. That in the industrial community can have some pretty big implications. So we wanted to make sure everything that we knew about it was correct before freaking anybody out. So we actually had to go and acquire a safety system, a Trigonic safety system, use the malware against it, not only reverse engineer the malware, but actually rip into it pretty deep. Towards the end of November, we ended up quietly informing international partners and CERT and DHS and DOE and bringing up the fact that this was something pretty significant.
And so when you say you discovered this through threat hunting, what can you share with us about what that process is like?
So what I will say is a lot of people, I think, have a weird perception of how you do collection, and the Kaspersky like silent signature discussion is sort of opened people's eyes to one side of the industry while thinking that it extends to everybody, which it does not. So normally there's a couple different ways to do this, whether it's at Dragos or anywhere else. The first is if you have access to customer networks. So like antivirus vendors or software vendors that see intrusions, they get collection out of their customer networks, and then they hunt through that data looking for malware and interesting aspects. Another way is to use malware repositories, whether it be VirusTotal or malware.com or other places that folks are submitting malware, even if it's accidental, and sometimes it's just by the vendors. And then there's also other mechanisms to do this. Some of our favorites are actually looking at the beginning of malware campaigns. Like if you were an adversary and you were going to go target industrial asset owners, how would you do that? Generally speaking, you might go after the vendor websites and vendor sites themselves. You might even test out your capabilities in smaller locations. There's just a lot of different ways to do collection, but generally speaking, the point is get a bunch of data, and then you're looking for things that are abnormal. For us, a lot of times it's an understanding of the industrial software paths, where we know on the industrial software side of the house, like what a correctly configured Trigonic system should look like. What does that actually look like? Now let's look for abnormalities compared to that and try to go from there.
So can you tell us anything about, was this discovered before any potentially dangerous action was taken?
No, it was discovered after the fact. And so I think it was discovered for everybody after the fact. I can't speak for everybody else involved in the investigation, but I know the incident occurred earlier this summer. And there was
Can you say what the incident was?
Yeah, and so we can, even without being in the customer site just by knowing sort of how these operations work, but it's also knowledge. There's also knowledge out there about what actually happened. But in sort of a 2-cent version, a safety system exists to govern the process and make sure that it's safe. You don't want to have gas leaks. You don't want to have overpressurized events. It's there to control the process. And so what occurs is if a safety system is compromised, it'll shut down the entire plant or shut down that portion of the process. That's a good thing. And a lot of people look at that as the fact that it's been compromised, but that's actually it doing its job. Its job is to shut down the process if something is unsafe. So when the Trisys malware got loaded onto the Triconic system, it ended up failing safe. The impact was the plant shut down, which is definitely a disruption and an attack, but everybody was safe in that environment, which is exactly what it's supposed to do. Now, looking at the capability and looking at some of the things the adversary was doing, we can make assessments, but not facts, about what the adversary might have been trying to do. And so as an example, based off of what we've seen with the capability, it looks like we know for a fact there was errors in the code, but it looks like the adversary may have made some errors in being able to change the logic on the safety system. So if you can think about it, the safety system says, hey, at these parameters, get involved in the process. At these parameters, I detect something unsafe. So if you mess up in changing the parameters, you'll drop the system, it fails safe, does everything it's supposed to do. If you do successfully change the parameters, what could come from that is potentially you taking out the safety functionality of that safety system, meaning that the adversary could do a different attack against the industrial process now without that safety net, if you will, being there. So you'd almost need 2 attacks to do something potentially life-threatening, but obviously we don't want to see anybody messing around with the safety system.
So this is potentially disabling the fail-safes. Is that a good way to describe it?
Yes, and so the impact at the site was specifically taking down operations. So there was an operational outage due to this malware. The implications of what the adversary appears to have been doing is that, in our assessment, they were trying to figure out how to remove the safety functionality from the system.
Just to back up a little bit to describe how these systems work. I mean, these safety systems run independently of the operational systems, and they're there to sort of watch over and take over if something potentially goes wrong.
Yeah, that's correct. A safety system is another type of industrial control system. It is very, very specifically configured as well. And this is where we try to capture the nuance of, no, this is not a highly scalable attack. Some of the other researchers accurately noted the Python code that was used, the framework that was developed, is scalable. You could absolutely use that in other sites. And you have a framework now to be able to go after other sites. But the nuance there is the framework is just that. It's a framework. The actual attack is specific to each and every safety system. And I don't mean just Triconics. So what generally happens is you go and you build an industrial process. You get super excited about it. You're like, I'm going to, build widgets, or I'm going to, in this case, oil and gas or manufacturing or some level of industrial process you build. Mm-hmm. And what happens is you do a process hazards analysis, and you come in, and you have the safety engineers, and you have people trained specifically for this to look at the process and go, and I'm dramatizing this, of course, but they look through it, they study it deeply, very deeply, actually. But they look through it and they go, all right, well, this is a decently unsafe process. We're going to say that people could definitely get killed here, or the environmental damage could occur. You need a safety level of 1 or safety level of 2 or 3, mm-hmm. Or like the hypothetical maximum, which nobody should be running. I don't think anybody runs a process like this, and I don't think you can even buy safety equipment for it, but it's like a level 4. Level 4 usually means like you did something wrong. Why don't you try to rebuild your process to be safer? But I also caveat this with, I always sort of advocate on knowing the limits of your expertise. I'm not a safety engineer.
Gotcha.
So this is just from my understanding. But generally speaking, you come in, you figure out what the safety level of that environment is, and you can do one of 2 things. you can either redesign the process to try to bring it into a safer condition, or if that's just not possible, especially in some industries like nuclear environments, oil and gas production environments, like that's just not possible to have it completely be, safe all the time. And so you then build a safety system out of the vendor technologies available like Triconics, and you tailor it specifically for that plant. And so its safety rating and what it's doing is absolutely specific to that environment, not just like a Triconics for an oil and gas environment, but specifically that physical process that was done. And so TRISIS is trying to take advantage of the Triconic system to change the logic to understand the process enough to change the safety parameters around it. And that's also why we noted there is no vulnerability in Triconics. And this is where I always, the media is getting a lot better. I have to admit, like a lot of the journalists that I've worked with over the years, they're getting a lot better about this. But of course, as soon as this came out, vulnerabilities in Schneider Electric Triconic system allowed a plant shutdown. No, that's legitimately not accurate at all. The functionality to change the parameters of a safety system are needed. Like using your own system has to occur. What the adversaries were in effect doing was learning the industrial process as well as an engineer for the purpose of changing the parameters so that it would no longer be in a safe condition.
Now, there were some errors that the operators made in terms of the sort of the physical status of some of the controllers on these Triconic systems. Yes, can you describe that for us?
No, and so I'm happy to talk about why I won't.
I guess what I'm saying in the report that you mentioned that there was a key switch in program mode instead of run mode. That's okay. What I'm getting at.
Different question. Good question. Okay, so I think it's useful for the audience. I'll sort of explain the previous hesitation as well as the one you're talking about.
Okay, great.
So the previous hesitation of like, no, I'm not going to go into that, is there were actually errors in their code.
I see.
And we don't want to publish on that because we don't really want to advise them on what they screwed up on. Because so you can't assume the adversary knows what they did wrong yet.
Okay, so you're saying attackers in the adversary, or the errors in the adversary's code is what you're referring to. Okay.
Yeah, and I think yeah, exactly. And so and maybe I used operator. I was thinking operators like adversary operators, but yes, the adversaries could have made this a lot better.
I see.
And we just don't want to tell them how. But and this is also like the weird thing, by the way, working at Dragos, when I've got people who have been on the offense, on the industrial side of the house as well, that are now defenders, and like, oh yeah, I would have wrote it this way, and you could have done this. And the defenders piece, yes, you should. There's two things you really want to maintain. I would say there's just two things, two key points in this scenario that make sense for the safety systems. Number one, you should not have the safety system itself, the SIS, the safety instrument system, should not be connected to the network. It should be a truly air-gapped kind of segmented environment. You want it completely out of band so that it can govern the process natively. This one was connected up. And so it was on the network where a remote attacker could get access to it more easily. Now, simply air-gapping it is not the standalone solution, but it's definitely a much better position to be in. And
is that done for convenience? They hose it up to the network for some reason of convenience for themselves?
Yeah, for that convenience, especially when you're talking about if you've got a lot of sites and a lot of remote sites, your ability to connect it up to access it is convenient. Right. But also sometimes it can just even be for you could almost say for safety, if your threat model doesn't, if your scenario, your risk scenario, I should say threat model, if your risk scenario doesn't include remote adversaries compromise your safety system, then it's completely reasonable to say, I would really like to get more information from my safety system to know that it's working correctly. And so I don't want to blame the victim. I don't think the practice is a good one. I think it's one that we should critique. But in the victim's mindset here, they could have done it for all the right reasons in the world.
I see.
It could have been done for even added safety. But in my professional assessment, it is absurd to network connect a industrial safety system. Usually, and I will say that this is one of the areas in manufacturing oil and gas that is contentious, because there are plenty of environments you walk into and the operator is used to going to a separate system, a separate network. It seems completely separate. And so they think they're doing all the right things. And if you look on the control network, it's not connected, but you might have level 3.5, which would be like your DMZ in the traditional kind of Purdue model. You might have a 3.5 that's actually shared across these. So in other words, one network out from where you are, there might be shared systems that then come over and use like LDAP and stuff for the safety environment. So I have seen a majority of them actually connected incorrectly, but no fault to the people involved. But or I would say no fault in the sense that they were trying to do the right thing. So long story short, that's one of the things that we recommend for everybody to segment that. And number two is the PLCs or final control elements, but the controllers for the safety system itself, you have a physical key switch that you can turn one way to program it. You can load new logic and things into it, turn it another way and it's on run. And unless it's already been compromised and has some sort of rootkit functionality to bypass the key, you're not doing anything in that system. So if it's in the run mode, the attacker can sit on that engineering workstation all day long and throw code at the controller. It's not open for business. So the attack isn't feasible in that way. That attack path doesn't work. Now, technically, if you're the adversary, you could do some other things to put a rootkit on the system that I don't want to go fully into, but it's not hard to figure out. And then it would bypass the functionality of the key turning because it's still logic at the end of the day. It's still code at the end of the day. But in this environment, we understand that the key was left in the program mode and that the safety system was interconnected incorrectly. So these two things led to an ability to more easily compromise this system. But before we move on, I do want to throw a giant asterisk here that, of course, as soon as I said that in the report with our team of you should do these two things as mitigations. And then we went on to say, and all of these other things, and here's how you should treat this scenario. The vendor community of the people who sell firewalls, segmentation devices, etc., jumped ferociously on that and said, see, if you bought our box, you would have been protected. And I just, for the purpose of education, want to note that is stupid.
Go on, Rob.
So segment your environment, use these type of devices, fantastic. But Monday night quarterbacking attacks to go, if the scenario was entirely different, like we would have won. Yeah, if I was taller and could dribble faster and dunk, I could be a basketball player, but that's not the world I live in, right? So like we need to realize that the attack would have looked different in a different environment. We saw this after the Ukraine 2015 attack as well, when people came out and Monday night quarterbacking like, oh, well, that couldn't happen in the United States because we have NERC SIP, and NERC SIP mandates 2-form authentication, so the attackers couldn't have remotely connected. It's like, dude, number one, it was distribution. NERC SIP doesn't apply. And number two, if the attacker was going after a NERC SIP certified location, they could read the standards of what you're going to have in place and design a different attack. So all of these things are important to put in place. They make your environment significantly more defensible. And I'm a huge fan of segmentation and firewalls. I don't think anyone that's serious in this conversation isn't a fan of those devices. But saying that you're going to prevent the attack, it is very disingenuous in understanding how these attacks occur.
So digging into some of the nitty-gritty of exactly what was going on here, what can you tell us about the technical aspects of what they were trying to do once they were in the system?
Yeah, so in general, once they established that from the engineering workstation, which is where you would program your control elements, once they were there, the code effectively validated that it had communication to the control environment, which also means, again, they were there before because you had to load in the actual IP address of the control element. Once you had the IP address of the control element and the software started verifying its connection, basically did a look through the code, look through using the protocols, the native protocols, to try to interact with the system to identify where could I load the logic, where is there place for me to interact with the system. After it found where it could upload new logic onto the system, it then tried to push new logic to the system. And that new logic, if it would have been successful, it is in our assessment, I'm very, very careful with my words here, it is in our assessment that it would have removed the safety function from the system, going back to our previous discussion on the system would have operated normally, there would have been no failure, The defenders would have had no idea the safety functionality of their system was denied. And then the attacker could have followed it up with an attack on the industrial process where the safety system wouldn't have kept it in check. Or they could have just waited and see if anything unsafe ever happens. And then it would just look like the safety system didn't work correctly. And unless there was really good forensics done later, you may not even expect this to be a cyber attack. That one's a little less realistic. It's more realistic that they would have caused a second attack on the industrial process itself. What occurred because of their errors or because they intended it. It's always difficult to get to intention, right? But it appears they did mess up. So what it appears that they messed up on is some aspects of their code and interacting with the Triconic system, which caused the safety system to do exactly what it's supposed to do and failed when it realizes that something is wrong. And then it shut down the industrial process, plant ground to a halt, and the engineers get called in to try to figure out what's going on.
So looking forward, I mean, this was discovered, and this is only the fifth known ICS-tailored malware. So this is pretty novel and new. Looking forward, how does this inform what you all do from here on out?
I think it's very clear to me at times that many of the ways that we try to inform the community are off IT best practices or off pen testing tricks. Like I say, we as like the general InfoSec community, and that's not appropriate. And so I like to be able to inform asset owners about the risk based on real threat data. I think the appropriate way to do it is, what are real threats? It goes back to people, like, oh my gosh, you can't have a sticky note on a substation like HMI. Like, why? Well, the sticky note has your password. Like, okay. Well, what if somebody sees it? I'm like, do you have cameras in here? Well, no. Okay, what's your threat model? Is your threat model the Russians are paratrooping into your substation? Because if so, sure. Is your threat model a remote adversary compromising your control center and pivoting your substation? Because that's your threat model. Give the operator his damn password so that he can actually use his system. And if it wants to be a complex password, there's no problem actually writing it down. Anyway, so there's a back and forth of logic doesn't always, the things we learned in InfoSec don't always translate to ICS. So for me, what this means for a portion of the community is a good case study on why some of these vendor recommendations from like Schneider as an example. Schneider had already made recommendations about before the attack ever occurred on how you implement a safety system. If you followed their best practices, the attack would have been significantly more difficult. This gives weight to that. With adversarial data validating some of the recommendations and helping us develop other recommendations, helping us move the community forward. So that's a good thing. Lessons learned here are good. The other thing that it does is it's starting to highlight more of the activity that's going on that most of us had suspected but couldn't prove. And in the absence of proving something, I don't think you should just guess. And so you really want to validate these things. So, speaking from a very biased perspective, because I run Dragos, but a very biased perspective, we really haven't had an ICS dedicated threat intel team in the community before. Like we have had one, critical intelligence, back in the day. They focused a lot on like vulnerabilities and research, which was fantastic. Ended up getting bought up by Eyesight, who ended up getting bought up by FireEye. And some of those folks are still there today, doing some fantastic work. But we really haven't had the threat intelligence folks that are actually going out tracking the adversaries and seeing what they're doing and really understanding down on the industrial side of the house what's going on. At best, we've had IT security companies who've seen adversary groups, but don't know exactly what they're doing on the ICS side of the house, but they'll report out on them. So what I'm trying to get at here is, there's more focus today, and there's teams that are focusing on it. So I expect to see more and more stuff. But in that vein of seeing more and more stuff, I would also note that more and more stuff is occurring. So we're sort of at this juxtaposition that you're going to see more ICS-based threats because we're looking. And so we're going to see more of the ones that already exist. But there is also a very apparent uptick in adversaries being focused on this environment. So we're also going to see more anyways. So to the layman who is not involved in security and is reading the media, get used to the words industrial and ICS, because you're going to be seeing a lot of it. And it's going to seem more scary than it actually is, I guess is my point. So in summary, I would say there's a lot of activity going on, and it's an increase in momentum that I'm not comfortable with, nor used to. But there is an aspect of that that's just looking and starting to see more and more. So lessons learned, is there are real threats out there. Obviously, we have to be informed off of threat data, not just off of pen tester tricks. And no offense to the pen tester community, they do a lot of great work. But when designing our industrial systems, we don't get the opportunity to do a tech refresh every couple of years. We really need to get this right. And being informed off of what the threats really are doing is a great thing for the community. So TRISIS, or also known as the Triton stuff, that malware is another good case study to help us make better decisions in the future.
Yeah, you mentioned FireEye, and they were, I believe, first to come out publicly about this, and they called it Triton. But you all take a different approach. You intentionally aren't the first ones out with information on these things. Can you explain that philosophy?
Yeah, absolutely. I don't trust the larger community, I should say. I'm sure I sound like some elitist jerk, and it's not my intention. But I don't really trust there to be a nuanced discussion in the global media when it comes to industrial attacks. And that trust is based on a lot of actual data about these things going wrong. And I hope that our international community grows up around news media as it relates to reporting on industrial threats. But I don't want to put my customers at risk waiting for that. So in short, if you're not doing the mission, knowing about the problems may not actually help you. It's probably the easiest way to summarize that. So our philosophy is when we identify a new threat, we work on it, we inform our customers first and foremost, and then when we think they've had at least enough time to process the information, we reach out to DHS and DOE and any of the international partners that reach out to us. There's a couple of governments that have reached out to us and said, hey, here's our line of communication. We would like to interact with you, and we give them the information free as well. So it's not like, so that you're in this weird position as a company like mine. So we're a software company, but we have an Intel team. And one way, my folks are persisting and growing that team based off customers. And so it is entirely fair to say my customers get more information. But I don't like holding information over the community to go, other people would benefit from this. We're talking life and safety stuff. Mm-hmm. I don't like being like, you're not a customer, you can't get this. It's both not fair to the company, but it's really not fair to the customer. And personal, or I guess the non-customer. And personally, between those two choices, I rather side on the side of the industrial community. So we still get the information out there where it's needed. The thing that I don't have time for is going and seeking out every cert in the world. We tried that, actually. When the crash override stuff occurred, we tried to make communications with literally every cert that had a public email address and phone number. And many of them ignored us, and only a couple came back in contact with us. And so I'm not going to go chase down your government. I'm not going to go chase down your national cert. But if they come and reach out to us, we have no problem sharing information. I'm not going to just give them all of our intelligence reports because I'm still running a business. But on things that they could actually influence, obviously, that's the right thing to do. So I could summarize the policy very easily to say the industrial asset owner community needs the information longer than it's in the public to actually be able to process the information and focus on it. We hear from our customers, and having been in the industrial community, I know that when something comes out and your executives and PR department is having to deal with a New York Times article saying, oh my God, we're all going to die, you don't have time to actually fix anything. So to even buy them 72 hours, a week, 2 weeks, 3 weeks, whatever it might be, is very useful for them getting their heads wrapped around it, going, hey, do we even have this system? Do we run this process? Well, what are our mechanisms to do security on top of this? It gives them time to focus on the issues. The race to the media is not appropriate. Now, FireEye did not race to the media, and this is the piece that I think is important to capture. Like, we put out a very strongly worded, like, hey, this is not how we handle business, and we don't think it's the way you should handle business. And that was actually in our community, like talking to other ICS vendors, because there are some of them who do exactly that. They find a vulnerability, they race to report it. They find a piece of malware, they race to report it. And that's not helpful to the community. FireEye actually did the right thing. They found it, and I don't think that actually. So this is where they'll have to speak on their own timeline. My understanding of the situation, and I was not on site, but my understanding of the situation was the asset owner found it. They called in Schneider. Schneider did fantastic work to try to uncover as much as they could. Then FireEye got called in. Then FireEye did the instant response after the fact. and then did an amazing bit of work on the analysis. So I don't know the exact timeline, but I don't know that FireEye actually found it. And that's not a diss on FireEye. I just think it's important that if Schneider did some good work, we also sort of give them accolades. But the FireEye analysis has been fantastic. They got a guy over there, Blake, who's going to do a lot more research on this coming forward. And I think it's going to be fantastic for the community. So I don't think they handle themselves incorrectly. But yes, our policy is very simple. We publish to our customers first, then to any of the international partners that can influence the change. Like if you're just some random cert that doesn't deal with ICS, then it's not useful for you to know this information. And we'll work with people as need be to get them information they need. We'll try to do victim notification if possible through the certs whenever the ones knock on your door. And then we always prepare a public report immediately. By the time we notify the DHS, and this is going to sound like another giant diss in the DHS. I actually really like a lot of the folks over there, but we know for a fact that when we notify any government or any government agency that there is a clock that starts on when it's going to get leaked. The U.S. government, specifically the DHS and DOE areas, do not have a great track record on not leaking these things. So we know when we pass it over that we have a clock to when it's going to come out. Sometimes it never does. Sometimes they do a fantastic job. Many times it gets out eventually. And so we already prepare the public report. In this case, we had a public report. We did not actually know when we found this. We didn't know FireEye had it. We didn't know anything about the larger context. We just were doing our job. But we went ahead and prepared the report for when it was going to get published. FireEye published it, and so we published ours.
So for those of us on the outside who are just, leading our lives, minding our own business, what's the appropriate level of concern for us?
Probably not a lot, because what are you going to do with it?
Yeah,
it doesn't impact you. I mean, or if it impacts you, there's nothing you can do about it. It's like those random events. I don't know an appropriate analogy. I generally hate analogies anyways, but if you have information that you cannot act on, you might as well not have that information. And so if you are doing vacations in industrial facilities, let's have a conversation about safety. But if you're living your life normally, what is useful to know is the industrial asset owners and operators and larger industrial community actually takes a lot of these things seriously. And although we definitely need to do more, and especially in some industries, not a lot is actually being done, and we want to do a lot more there. But in some industries, they do a ton of things. You've heard me plenty of times talk about the power grid operators in North America, where they do a lot of training and exercises and tabletop exercises of how they would respond to these events. We've got customers that don't have safety systems in their environment, and still they're like, okay, well, what if this wasn't a safety system? What if it was this type of system? And what if it did these things? Let's walk through what we do in that. They take it very, very seriously. And so to the larger community, I would just say, just because you're not getting information about all the good work that's being done, please don't assume it's not being done. And I honestly wouldn't fear in the scenarios we're talking about. If there's loss of life conditions, the people I worry for are the people at the plant level. It could be far worse, but so could a lot of things. I don't think that there's value in people fearing about these things. I mean, look at what it's done. Look at what that fear has done to the nuclear industry. Nuclear energy is one of the cleanest, safest forms of energy that we have. But the fear from Hollywood to media to anything else around radioactive monsters and all this, it drives a fear that has crippled that industry to where we have to look to other sources. And the people that operate those types of plants almost operate at a loss, but do it because it's a good energy source to have as a base load for the American power grid. So I don't know. I'll just say to the larger industry, fear and hype is always going to lead you to a bad situation. And put undue pressure on the people that are operating equipment. And if we're so scared that we ask them to, change the way that they are doing business, not from a safety perspective, but from like a PR perspective, you're going to be pulling resources away from the safety perspective. If we let fear and hype drive or motivate or push unnaturally the evolution of that industry, we will get an answer that looks different than the right one. So I would just say to everybody, we don't generally see New York Times headlines on power is still on, things are working well. Like, don't worry. There's a lot of good people doing a lot of good work.
Our thanks to Robert M. Lee for joining us. You can find the complete report on the Trisys malware on the Dragos website. It's in their blog section. The CyberWire Research Saturday is proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technology. It's produced by Pratt Street Media. The coordinating producer is Jennifer Iben. Editor is John Petrick. Technical editor is Chris Russell. Executive editor is Peter Kilpie. And I'm Dave Bittner. Thanks for listening.